All right, so we have been talking about ions lately and writing the electron configuration of ions and the Lewis structure of ions. Right now we're going to look a little bit deeper into writing the electron configuration and the Lewis structure of ionic compounds instead of just ions by themselves. Now, an ionic bond is what we see in an ionic compound. An ionic bond or an ionic compound is made of one metal, one or more metals, and one or more nonmetals. Okay, so we always have metal plus nonmetal, and when we represent them as a chemical formula or when we name them, it's always in this order: metal and then the nonmetal. So we're going to see what this looks like, the electron configuration for magnesium and oxygen up here. Okay, so I'm going to highlight magnesium and oxygen on our periodic table, just so that we're clear where they are. Magnesium and oxygen right there. All right, so now that we see where magnesium and oxygen are, we can write the electron configuration for each of them. So the electron configuration for, oh, that's not the color I want, for magnesium is, if we're going to do the abbreviated, which is going to be a lot easier, we're going to find the noble gas right before magnesium, which is neon. So we're going to have neon in brackets. And then if you look, after neon, we have 3s2. So neon, 3s2. And there's a configuration of magnesium. Now, if we want the configuration of oxygen, we're going to write that right down below, oxygen. Again, abbreviated configuration. So we find oxygen, the noble gas right before oxygen is helium. So we're going to have helium in brackets. And then it's going to be 2s2 and 2p all the way over 1, 2, 3, 4. So 2p4. And there's our configuration. That's kind of sloppy. There's our configuration, electron configuration for magnesium and oxygen. Now, we know that magnesium with 2 electrons in its valence is going to rather give up those 2 electrons than gain 6. Okay, so these 2 electrons are going to be given up. In oxygen, we see 6 valence electrons. It's really hard for oxygen to give up 6, so it's actually going to take 2 more so that it has a full valence of 8 electrons. We can represent that here and show where those electrons are coming from, because we see here, that magnesium has 2 valence electrons. Well, conveniently, oxygen wants those 2 valence electrons. So those 2 electrons are going to go to the 2p sublevel in oxygen. And what we get is magnesium with a 2+ charge, because it's now lost 2 electrons, and its configuration, it just lost the 3s2, so its configuration is simply neon in brackets. We also have oxygen, which has gained 2 electrons, so it has a 2- charge, and its configuration is the same that it was, helium in brackets, 2s2, and it gained 2 electrons in its 2p, so it's 2p6. So we have helium in brackets, and 2s2, 2p6. Okay, both of them have a full valence. Magnesium now looks like neon. Oxygen also looks like neon, right? Neon in brackets up here. Oxygen with 2 valence electrons more, it also looks like neon, okay? Remember that ions are always going to have the configuration of a noble gas. Once they've formed an ion, they're going to look like noble gases. So that makes sense what we're seeing there. All right, we're also going to look at the Lewis structure of how this bond forms. Okay, so I'm going to draw the Lewis structure for magnesium, which if you look here, it's in the second group, so it has 2 valence electrons. So I'll draw my 2 valence electrons. Remember, they're paired over there in that s orbital. All right, and then we have plus oxygen. Now, oxygen, if we're looking on the periodic table right here, is in the 6th group or family. So it's going to have 6 valence electrons. So I'm going to draw those in. 2 paired on the right, 1 up, 1 left, 1 down, 1 up. Okay, so you can see oxygen has 1 unpaired electron here and 1 unpaired electron here. Remember, both magnesium and oxygen want to look like a valence electron, they want to look like a noble gas. So they want full valence shell or valence orbitals. So we're going to take one magnesium here. It's going to bond with that unpaired electron in oxygen. And this other electron on magnesium is going to pair with that other unpaired electron in oxygen. What we get then is, again, magnesium has now lost two valence electrons, lost both of its valence electrons. So we have magnesium with a 2+ charge. And we have oxygen over here. Now, notice magnesium lost its two valence electrons. So we don't show any valence electrons on magnesium. It just lost those two. Oxygen, however, had 6. It gained 2. So we're going to show 8 valence electrons on oxygen. All of them are paired. All right, so now this oxygen, it gained 2 electrons, right? These 2 electrons coming from magnesium, oxygen gained them. So oxygen has a 2- charge. Now what we see is we have one, in both instances, in the electron configuration here and the Lewis structure, we're showing the same thing in 2 different ways. We have one oxygen bonding with one magnesium bonding with one oxygen. And we get the compound MgO, which we call magnesium oxide. Okay? When we name these, the metal always maintains its same name. The metal ion is magnesium. The oxygen anion is actually an oxide ion. The ending of the anion, or the nonmetals, changes to "ide", so oxide. Okay? Let's look at one more example. Oh gosh. This is going to be magnesium and chlorine. So I'm going to highlight on our periodic table the magnesium, which we already saw in the last one, and chlorine. Okay, again, remember, one metal, or one or more metal, and one or more nonmetals. Here's magnesium, it's a metal. Here's chlorine, it's to the right of the stair-step line. It's a nonmetal. Okay, so this is going to be an ionic bond. These electrons are going to, we're going to have electrons, how to zoom out. There we go. We are going to have electrons given and taken in this ionic bond, just like we had at the last one. Magnesium is the metal, it's going to give up electrons. Chlorine is the nonmetal, it's going to take electrons. As long as one's giving and one's taking, then they are happy. So we're going to write the electron configuration of magnesium, which we just saw in the last example. We have neon in brackets, and then we have 3s2. Okay, configuration of magnesium. For chlorine, we're going to look up here. We see chlorine, the noble gas right before chlorine is also neon. So we're going to have, again, neon in brackets. And then we're going to have 3s2, 3p. And look over here. It's a halogen, so it's in the 7th, but it has 5 in the p. So 3s2, 3p, 5 for a total of 7 valence electrons. Now, magnesium has 2 electrons to give, right? It's not going to gain 6. That's too hard. Chlorine has 7 valence electrons. It's not going to give 7 away. It just needs 1. So we see one of the electrons here from magnesium is going to go to chlorine. Great, chlorine's happy. Now it has 2 plus 5 plus 1. That's 8 valence electrons. Chlorine now has a configuration of argon. Magnesium, however, only gave away 1 of its valence electrons, so it doesn't have a noble gas configuration yet. So it is not happy. What must happen is that we have another chlorine. So we're going to make that 2 chlorines. So another chlorine is coming in. Again, 3s2, 3p5. Okay. And the other electron from the 3s in magnesium is going to come down here to 3p in chlorine. So now magnesium has given both of its 3s electrons away, and chlorine has gained, 2 chlorines have gained 1 electron each. So what we have then is magnesium gave 2 electrons away, so it has a 2+ charge. And now its configuration is just neon in brackets, okay, because we lost that 3s2. Whereas chlorine, we have 2 of them. They each gained 1 electron, okay, so that's not 2 minus. Each chlorine gained 1 electron, so it has a 1 minus charge. Each one of them has a 1 minus charge. And their configuration is neon in brackets, 3s2, and instead of 3p5, 3p6. Okay, so neon configuration up here, magnesium 2+ is happy. Chlorine minus has the configuration of argon, also noble gas, so it's also happy. Okay, so now we're going to look at the Lewis structure for each of these. So magnesium, its Lewis structure has 2 valence electrons. Chlorine, again, is in the 7th group, so it has 7. So I'm going to add my 7 valence electrons for chlorine. Okay, one of the electrons from magnesium is going to come and pair with that 1 unpaired electron on chlorine. Great, but chlorine is happy, magnesium is not. So we're going to need another chlorine. Okay, again, 7 valence electrons in chlorine. This other magnesium electron is going to come down and pair with that unpaired electron in chlorine. Now we see both magnesiums are happy. Magnesium is happy. Both chlorines are happy. All of those ions, so the magnesium ion and the chloride ions, have full valence shells, so they're happy. We now have magnesium, which has lost its 2 valence electrons, so we're not going to draw any valence electrons on it, but it does have a 2+ charge because it lost its electrons. And we have 2 chlorines. Now chlorine has gained an electron, so it hasn't lost them. It had 7, it gained 1, it has 8. So we're going to draw those 8 valence electrons on chlorine. And each of those chlorines now has a minus charge. Okay, so we have, in both of these instances, whether we're looking at the electron configuration up here, where we have, 1 magnesium and 2 chlorines, or whether we're looking at the Lewis structure, where we have 1 magnesium and 2 chlorines, we have the formula MgCl2, 1 magnesium, 2 chlorines. And the compound, magnesium, remember magnesium, the metal name stays the same. The non-metal changes the ending to "ide." So instead of chlorine, we have chloride, magnesium chloride. 1 magnesium to 2 chlorines.